everyone. My name is Victor Gamov. I work as a developer advocate here with Quonk, and I'm enjoying this very much because I get to talk to developers. I got to talk and learn from the builders, people who build the platforms, people who build solutions, build APIs. I will be doing things, but you can also follow along with me. Many of you, if you follow me on Twitter, please do, and you have any questions, you can always ask me in my Twitter DM. That's my Twitter. If you want to go and follow me, that would be fantastic. In order to follow along, Dalia just shared a link in a GitHub, so it's a GitHub link to my account where you can get instructions. So this is the repository that includes a bunch of stuff. But most importantly, this repository includes instructions. In case of you need to drop off, or in case you, stuck somewhere, you can use those instructions and learn what you did wrong. So in this case, when this workshop will be over, you still will have something to play around with. We're not gonna be doing anything with the code today, maybe in a future session, but let's assume you are already developed some microservice. I will show you some of the code of this microservice in order to understand what it does. So you need to understand a little bit of code, and by code I mean real programming language, not the YAML. I will be showing you some of the code from either Java or Kotlin, but all concepts that I will be talking today will be translated to any language. So once we get there, you can either clone this repository or you can follow along with these instructions. So in these instructions, we will be introducing Kuma as a service mesh, a few applications, 2 microservices that will be talking to each other. They are containerized, and we're gonna be using a Kubernetes. So if I go to prerequisites, the first link that you can find is that requirements for attendees. We already checked some basic knowledge for application development. So you need to be familiar with containerization and Docker. Specifically, you're not gonna need know all the bits and bytes of this in order to do the workshop. But it is important that you understand what we're doing here. There's 2 options for you. So I know some of the people, if they want to follow along, you need to have some sort of Kubernetes cluster. I will be using a Kubernetes cluster that is deployed in Google Cloud because it is a public thing. I want to show you some of the public stuff, specifically things when I need to external IP address and the external load balancer. So I don't want to go through this nonsense. So in this case, my Google Cloud cluster slightly over provisioned. You don't have to have a big one like this. However, if you are planning to do something locally, I also get you covered. So you can do things like this here. And one of the things that you will see here is the makefile that includes some of the commands that you can use. Minikube, it's the thing that I used to test these instructions. And those instructions actually works fine on Minikube. You can run the Minikube. You need to download this and install Minikube. And after this, run this. In order to run Minikube, you need to have Docker running. So in my case, I don't have a Docker running because I'm not going to be using Minikube. So the next thing is that you also need to have installed is kube control. And kube control, this is how we pronounce kube control in this stream. When you're talking to other people, you can tell whatever you want. Here, we're pronouncing this as a kube control. So kube control is command line to interact with Kubernetes. If you do anything with Kubernetes, you need to have it. You need to have it. Please install. Another thing that significantly simplifies your life is this small tool called K9S. You will be seeing this all over the place. If I'm running this here, nodes, for example, that's K9S that I'm running, and I will be using this to show you or navigate throughout Kubernetes cluster because it's faster for me. But again, 100% optional, but I highly recommend if you do anything with Kubernetes, use K9S. And also, it's good if you will have an Insomnia installed because I do have a collection of requests already available to you in this GitHub. So there's a JSON file that you can import to your Insomnia, and you can also follow along with some of the instructions. I was trying to make this as easy as possible. Specifically, I put multiple nodes. I highly recommend people to use real Kubernetes clusters somewhere if you have access. I am extremely happy and blessed that my employer sponsors my Kubernetes cluster. But if you cannot, use Minikube. Now, for the next thing is that we're going to do quick outline. So it is ignore the times. Usually I use these times when I'm in the classroom of the people. This one is going to be super fast paced, meaning that we will have some time to explain some of the concepts, but I will not have it all the time of the world to explain all the things. So that's why almost every 2 weeks or every 3 weeks, we have a live stream on the Kong YouTube channel called Kong Builders. And in the Kong Builders, I have more time to talking with people and explaining some of the content. So make sure when you come to Kong YouTube page, and in the Kong YouTube page, you have this subscribe thingy, and it is also enabled notifications. So you will not miss some of the live streams. That's my personal request. If you didn't subscribe, please do, please do, please do. We're going to start with introduction of the service mesh. We're going to install control plane of the service mesh. We're going to deploy some of the existing applications for service for containers. And we start enabling some of the traffic policies to control things between the microservices. We install some of the observability stack in order to have a visibility in our application. And we will have a quick recap at the end. So we're going to be talking about the Kuma. Kuma is CNCF project. We developed Kuma at Kong, and we donated this into a Cloud Native Compute Foundation. Kuma, it is a service mesh implementation. It uses Envoy as a sidecar technology, and it is based on the open source standards, and it is also open source. We at Kong, we use Kuma as a foundation for some of our commercial offering called Kong Mesh. We're not going to touch Kong Mesh today. If you're interested to learn about Kong Mesh, come to my Kong Builder talk or watch some of our videos available in our YouTube channel. We're going to be focusing on Kuma today, so only like open source stuff. The first thing that we need to do, we need to install a control plane. That's the brains of our operation. Kuma control plane, it is a service that will be running inside Kubernetes cluster, or like pod or application that will be running inside your Kubernetes cluster. And this will be controlling some of our things in our application. Also, control plane is responsible for keep connection with these data planes, small components that will be injected next to your application. And those components will be providing some of the traffic shaping capabilities, like enabling security, MTLS, and enabling some of the routing policies and things like that. So that's the answer. So control plane is not participating in any traffic exchange, meaning that if the control plane goes down, your application communications, your things still will be intact, and the traffic between your applications still will be continuing to flow. Also, through data planes, we will be able to enable some of the collection of some metrics, traces, and logs from our applications. Because of the nature how this sidecar or this data plane thing work, it will be able to intercept some of those useful information and inject this information into the storage where we're going to be querying this. So we're going into a setting up a Kuma service mesh. If you decide to participate and you follow along, if you want to do this, there's a few options for you. So first thing is that you can follow the standard installation guide, and it is like also automated script that download the Kuma and install it. Also, you have, if you download my zip file, you can find this the make file, or like you clone this repository. This make file includes a command called make Kuma install. That will download and install Kuma, in your computer. So when I run this make Kuma install, it will actually execute multiple things here. If I go to Kuma install, you will see that it will download the Kuma, run the installer, and after that, it will execute this command. So how you can check if you have a Kuma installed, you can just do Kuma CTL. Kuma control, of course. And I don't hear anyone corrected me. In order to validate if you have a Kuma control installed, you need to run a Kuma control version, this command. And the Kuma control version will speed up something like this. And this is absolutely normal. And you can find the same thing in the documentation. We are not running anything on the server side. We're not running control plane because we didn't install it. If you don't want to follow automation route because it can be too complicated or difficult for some people to understand, in documentation, I have a step-by-step instruction. So we're going to be going through documentation, step-by-step example, and advanced people can look into automation. And maybe you can find that my automation sucks, and you can go and submit the PR to this repository. Again, this repository is fully open, and if you find something interesting to add, please do. So we're going to start this by running this command. We run this Kuma version. The next thing is that I want to create a namespace called Kuma system. I create this namespace, and if I go to my K9S, I can see this Kuma system namespace. And if I will do, let me do this so you can see if things will happen at the same time. So I have on top, I have my K9S running, and this the commands that I will be running inside my cluster. So I'm going with this command called install control plane. So Kuma control allows you to do multiple things. If I'll just do, you can do multiple things. You can install various components. You can install various components. You can generate different resources. You can communicate with your control plane using this command line. So we're going to be using this command, install control plane. You can do install of multiple components. You can install control plane. You can install even demos. Kuma comes with the ready-to-use demos. We're going to be using this for installing some of the observability bits as well. And yeah, so you can do this with this command. Kuma control install control plane. Now, when I run this, okay, typo. So it will install CRDs. When we're running this inside Kubernetes, we're going to be following the Kubernetes native way of dealing with configurations, specifically custom resource definition for configuring mesh, for configuring different traffic policies, and things like that. People also let me know in the comments if you're still following along and we're still doing the thing. So I know that I'm not talking to myself only, and there's some people they're still present. Now, when I execute this, what we see in the namespace, again, Kuma system, we have one pod called control plane. And in order to do something with this, interact with this control plane, we need to execute next command. So first of all, we validate that our deployment is up and running. So we go in here. So control plane up and running, no zero restarts, all good. Next thing is we can use a port forwarding command in order to show Kuma UI. So port forwarding will tap into the control plane service to the port 5681, and we'll see dashboard. So since I need to use this terminal, I'm not going to use this command. I will be using a K9S feature that will do the same thing because I need to do multiple things on the screen now. And if I go to localhost port 5781/GUI, we will see this very nice UI with some circles and things like that. And now, if you will be able to do thing with the Kuma control version. Since we'll have the port forwarding connection, we also will be able to get the server version from Kuma server. So if you go and hit this URL directly, you will see this JSON that says like what kind of version of control plane, host name, and trace ID. And when we go into this to GUI, one of the ideas that we have around Kuma and how the Kuma can help developers to build their stuff is that usually it's the new technology is very intimidating and people are don't know if they're doing the right thing. So we put a lot of effort in order to optimize developer experience. So when you first time run this, there would be a bunch of kind of like wizards or like a help items that allow you to get up to speed. So for example, you said there's a pro tip. You might want to adjust your mesh configuration, and it will provide you with the list of things that you want to enable in order to make your mesh is more powerful. We're gonna ignore this because we're gonna do this anyways. So we're gonna switch this. But also, you have a full blown tutorial here. So if you not attending this awesome workshop and that you're not doing this, you can go and put the getting started. You can install demo application. You can send some traffic here. So this is going to be awesome. Everything that you need to know, everything that you need to see is this GitHub instruction. There's documentation that says which command to run. And after that, open this UI. If you, at this point, you said you're going to be following along and you at this point see dashboard, you already have a service mesh installed in your Kubernetes cluster. So you have installed a control plane. We have a bunch of interesting things installed, so we can go and follow along. So now we're going back into this. So we got this setting up Kuma. We're already done. So now let's deploy some applications. So before we're jumping into this application, I want to spend like 1 second to explain what those applications do. There's the different flavors of this application, but specifically, I wanted to focus on two microservices that we're going to be using. One is microservice that says like Victor does work, and another one, if we go into implementation of this microservice, and it actually has a REST controller that has a path called work. And what I do when I'm working, I'm going to meetings. So when I go to meetings, when I work, I go to meetings. But what I do on those meetings, so my work application will call another application that will have a meeting point. Actually, let me run this locally. We have a few minutes. I can run this locally. You don't have to run this locally, but if you want, you can. That's why I said you can use some of the Java stuff. So my meeting application. When I go to meetings, what I do on those meetings, don't tell my boss. But that's very busy job that I do on the meetings. Every time when I go to meet with someone, I actually will be sleeping, and this is where insomnia comes into play. So inside this repository, you will find file called insomnia.json. So insomnia.json, there's a bunch of stuff here, but if you open this in Insomnia, you can go into create and then click import. And you say either, let's do clipboard, would be easier. So I can copy and paste and do clipboard. And I click scan, and Insomnia will be able to import this. And just do mesh workshop. So I will create new Insomnia collection that will include a bunch of different requests. If I go to debug section, I will see some of the requests that I can test. Specifically, if I can go to localhost.meet, I should be able to see that there's my application, that result send the response, and it takes me roughly 255 milliseconds, which is what I wanted to have. So this is sleep time for 1/4 of the second. Another application that I want to use, it is called work, a REST controller that you saw, and this application will call this 4 times. I will call this 4 times, and after that, I will provide the response, how long it took me to do the work. So if I run this, when I run this and I go back to my Insomnia and I call the work, so it should run on different port. And when I click send, it took me roughly 1 second. Let's call it one more time because it was, so 1 second to do 4 meetings. On the meeting, I do sleep 250 milliseconds. 4 times is 1 second. And I get the output here that I actually went to work. So a couple things that you can notice here. 2 microservices. One microservice do the thing, another microservice will call and use result of the service. That's kind of like a normal operation of these two systems. Since we're not running this as a one big monolithic application, we'll run them as a 2 services. And there's a few interesting things in 2 small applications can be done. So first thing, how we can find the URL for our meeting service. And in this case, this meeting service URL needs to be injected through environment variables. I'm not going to spend a lot of time to talking about 12-factor apps, but one of the factor of these modern microservices and 12-factor apps is to have a configuration that would be separated from the code. And one of the things that we will be injecting based on the environments, the location of this meeting service, because we're going to be deploying them in Kubernetes, and we'll be using service mesh to do like some of the fun routing for those applications. But again, 2 applications, we're going to be publish this as the containers, and we deploy them in the Kubernetes cluster, and we enable service mesh, and we will start observing different traffic things with this. If you're not, for some reason, comfortable with Java, I do have another version of those applications that does absolutely the same, but they use Kotlin. And so if I go to configure HTTP, where's my plugin? It does absolutely the same. It will be using Kotlin, a framework called Ktor, to use whatever like configuration parameters to get the URL from environment variables, and it has built-in HTTP client that can communicate to those systems. So maybe in the future, if this workshop will be a huge success, I can show you how we can do blue-green deployment, for example, with service mesh, if you're interested in this one. So write down in the comments, or if you're watching this in the recording, or if you're in a Q&A session, some of the things that you want to see in the future. Maybe you want to see how to do blue-green deployment of this applications. That would be one written in Kotlin, another will be written in Java or whatnot. Now, we're getting back into our deploy demo application section. So now you understand these 2 applications, and now it's time to deploy this. We're gonna create a new namespace called Mesh for Devs, and we're gonna be putting this into our console. We created namespace, and also we need to tell somehow to Kuma to monitor this namespace. So that's why we're using this sidecar injection label for this namespace. If I go here and enable sidecar injection, meaning that Kuma control plane that we deployed earlier will have a ability to listen this namespace and insert this sidecars inside to your application. So you as a developer or operator, you don't need to configure those things manually, even though you still can do this. Now, in order to deploy these applications, I already prepared the scripts or YAML files for you, so you can deploy these applications yourself. So if you go to Kubernetes folder, you can find the customize file that we're going to be using. Personally, I'm a huge fan of Scaffold, which is a pretty cool tool to deploy your applications and undeploy these applications. But in order to simplify the things, we're going to be using standard customized thing that is built in the kube control. Now, we deploying our meeting application, and deployment is very straightforward. Deployment includes one replica, and it deploys this container. This container available in Docker Hub, so you don't have to build this container yourself. This should just work in our case. So let me stop this one, and let me stop this one. Also, we put a service, Kubernetes service, in front of this application. So these applications will be routed within Kubernetes cluster. So for work application, thing will look pretty much the same. We have a deployment with one replica, with another container that will be including just the work application. And in environment variable, we need to insert or inject a URL for our meeting application. So in this particular case, since we created this meeting service in the previous step, in the previous deployment file, this meeting application will be routed within namespace. We're going to deploy these two applications in the namespace. And since we are using this Kubernetes, this will be visible for another application to get access to it. I will show you different ways how we can change routing because sometimes the ports are cumbersome, and sometimes you can deploy this application in a different namespaces, or maybe you can deploy this in a separate cluster, but it's going to be part of different mesh. Again, multi-mesh and multi-regional deployment is out of the scope today's conversation, but if you're interested about this, please write down in the comments. So in this case, our application will receive a link or a URL for our work application. And in order to deploy this, we're going to be using this command. So 2 services created, 2 deployments created. And if I go to and check if the pods are up and running, 2 pods are up and running. So we should be able to see, if I go to namespace, mesh for devs, we can see our work application is running and our meeting application is also running. Now, let's quickly take a look. What do we have here? So we do have, if I go into this namespace, I see bunch of the pods, but inside each pod, I will have a multiple containers. So the meeting container, that's my application that runs this meeting application. But also you can find here a few more containers. There's a Kuma init and Kuma sidecar. So init container will start before other containers will start and configure a network. So all the traffic will be routed through sidecar. So sidecar is something that the control plane was injected in this pod, and the sidecar will be receiving all the traffic. How I can see if this thing is working? So on the previous steps, we enabled a Kuma manager, Kuma UI. So if I go here and quickly, let's do refresh, I see services, and 2 services will appear here as well. One service for work application and another service for meeting application. That's something that we already see. Those applications are here. So if I want to go into my, say, service, and I'll take the work application, so work service, and I want to invoke the work service and see if the thing actually works inside Kubernetes. So I can go ahead and do port forwarding for this, and the port going to be port 8081. Now my port forwarding thing is routed to this service. So if I go to Insomnia and I'll just do localhost and I click send, I'm getting this response now from the cluster. How I can see if it actually comes from the cluster? I can go and see my work application, and I see that I went for meetings. My URL of the service was injected, and everything works fine. So 2 services now supposed to be running inside my Kubernetes cluster and inside my service mesh. And one of the things that I also can see here is that my meeting application spits out all the headers that coming into. So it knows that the stuff is coming from user agent from Java 9 because it was set in my application. But also service mesh now includes some of the additional headers that our sidecar injected. So request comes in because we use this init container. Init container changes the networking. The request will go first to our sidecar, and after that, sidecar will route into my application. We get the response back, and we send this back into my work application. And we did this for 4 times because we're calling this service 4 times. And we will be able to see all these things, information that service mesh automatically start collecting. Now, port forwarding is nice. But we can do better. Let's do this. Port forwarding. And let me kill this port forwarding for work application. So let's make sure it's not working anymore. So could not connect to the server. So port forwarding is not working. Now, inside this code, you can find there's a mesh folder. And inside the mesh folder, you can find a gateway YAML. At this point, you have a choice where we can go in this route. Usually at this point, I have a conch gateway also deployed somewhere in my Kubernetes cluster, and I can connect my conch gateway that will be controlling my all the traffic that comes into my application, and tell this traffic to go to the gateway. But we take the Okuma's blade and start removing all these unnecessary bits. So in order to simplify and not introduce unnecessary complexity, at least for this workshop, I want to show you very cool built-in feature that is available on Service Mesh, specifically on the Kuma. We call it a mesh gateway. So right now, all the services are running inside Kubernetes cluster. There's no external access to those. But we can deploy special type of the data plane, special type of service that the Kuma will be managing, similar thing that the Kuma manages itself with control plane. Same way as the Kuma manages some of the data planes that will be injected into your applications. We also here have a gateway, the special type of the service. And what it will do, it create a load balancer with external IP address and route all the traffic that will go to this IP address into our work application. So anyone in the public internet, I'll show you IP address, you will be able to hit this and we can start seeing how does it work. So the way how it's done, this is not an instructions because I decided to add this last moment. So that's something special for you, for your treat, for those who join us into this live show. So if I'll just do kube control apply file inside the mesh folder, and I'll just do gateway. Let's quickly look at this one. So it will create a service with name mesh gateway with type of load balancer. Also, it will allocate port 80 for HTTP listener, gRPC listener also supported. And after that, there's a mesh gateway route. Mesh gateway route will create a rule that when the request comes into this route, all the traffic will be routed to this work mesh for dev service. How we know this? This is Kuma IO service. We know this name of the service from our UI. So if I go here and go to the services, this is our work mesh for devs SVC in the port. So that's the name. That's the how we can route to this thing. Now, if you refresh the screen, you will see there's a new gateway appeared here, and the gateway new type of data plane here, and the type of called built-in. So Kuma supports two type of gateways. One gateway would be built-in. In this case, it will be managing all the traffic that comes into this. Or it also supports a delegated gateway where we can use gateways like a conch gateway in order to front all the traffic that comes into service mesh. So let's take a look if this actually works. So what I will do, I'll just do to all namespaces, I'll just do service. And specifically, as you can see here, there's a special service, mesh for devs gateway. The service that we created here, and this is what we have here, mesh for dev gateway. This is the name, and we have an external IP address. That's the IP address that if we will hit with my Insomnia, I'll go in here and I'll just do hit the gateway. It has a predefined. It has a predefined IP address that I have from previous tests. But if I will put this IP address here, and if I will call this, so what happens is now everyone who has access to internet, obviously you watching this, so you have access to internet. So we can do something, generate client code. That's another cool feature that Insomnia provides. You can generate the code and share with everyone. So if you run something like this, I can share with you inside the chat. you will be able to access my work application and also create some of the additional traffic for my application. We're going to need this traffic information when we will be enabling some of the observability bits. But we also can start playing with this. Now, everyone can start playing with this, either from Insomnium, from curl. You will be accessing this application. So let's now go back into policies, 04 policies, and enable some of the cool things. So first thing is that let's enable some of the policies around the traffic route. One of the things that we can do with this traffic routes is adding some additional headers. We can include header inside response. For example, in this particular case, we will be including the version of the application that we want to include. In this particular case, we're going to be extra header, X work header. So we would know that the work application will include this header. So if I will just do things around control apply inside my mesh folder. Okay, so I think I messed up somewhere. In this case, the namespace actually is not very relevant because those policies are applicable to mesh, not the particular namespace. So if I will run this, it should work. And inside my Kong manager, Kuma manager, I will see there's a bunch of policies. And one of the policies that we just applied is called mesh HTTP route. So we created this HTTP route policy, and always you can see in the manager, you always will be able to see what kind of like a data plane proxy was affected. And I can see this, the work one was affected, this one, and we know what kind of policies applied here. And you can see there's like a traffic routes, different traffic routes that you configure. And there's a mesh traffic route that we just created. The next thing is that what we can do with this, with the policies, is to enable MTLS. So MTLS allows to Kuma control plane manage secure traffic across those data planes. And in order to do this, we can create this file with the enabled built-in certificate authority. And certificates would be generated automatically by Kuma control plane. So in order to do this, there's a couple of things, a couple of ways how you can do this. You can do either this through reading documentation, how it can be done. And it has a configuration for built-in control plane, built-in certificate authority. But also you can provide your own certificate authorities. You can integrate with certificate authorities that provided by some other solutions like Vault and Amazon, but it's the part of kind of like an enterprise version. So that's what we're going to be doing this with the standard. We just like use this example, create MTLS thing and stuff. Let me doing this like quickly jumping into this. We still have 10 minutes. I want to still show you. You can play around with these policies enable. You have a UI that you can play around with this. Now, I wanted to kind of like jump in front because I do have this mesh.yaml file that already have everything pre-configured. And I really want to show you observability bit, how you can enable kind of like a deep insights into your application and what you can do with service mesh and how you start collecting this data. So inside this mesh, I have this MTLS configured, and I also can have configured different backends to collecting all these metrics. Prometheus for metrics, Jaeger for tracing, and Loki for logging. So if I jump into observability bit, so I can go and create observability things. I will create install Kuma control, install mesh observability. Will install everything you need to show the demo with the mesh observability. Will install Jaeger, will install Grafana, will install Prometheus, and we will configure service mesh to use those. Now, I need to apply this resource. So I go ahead and just do kube control apply file mesh, and I will just do mesh.yaml. Going into my manager, I will refresh everything. So now what I can see here, few more services was able also added here. So service mesh also manages the namespace that has observability things, so we can also see what is going on there. And also, as you can see here, I need to configure now. Where is it? Mesh. Our observability pods up and running. Yes, so they are up and running. So we can go into services, Grafana. I will expose Grafana through port forwarding. So Grafana was installed with the Kuma control apply command. So I'm going into my Grafana in the local host. You should be able to see this. You can do this with commands that I have in the file. You can use admin as a password to log in the Grafana, and it will ask you to create the password. You can skip this. You don't have to do this now. And one of the things that you will see immediately here is that once you deploy this Kuma control, install observability, we'll also deploy a dashboard. This dashboard will include a bunch of stuff. So, for example, we can see like statistics about gateway. And if I will generate some data, say insomnia, send repeat on interval every second. So insomnia will start generating some of the traffic. So I will start hitting this application. We will see the traffic in the real time. Let's just do quickly refresh. And this is how we can monitor the gateway immediately inside this the Kuma dashboard. And the next thing is that let's see if our data sources are up and running, and we will be able to collect some of the data. So it says data source connected, but no services received. So meaning that we also need to enable policies to start collecting traces. And it is called like a mesh trace policy. We need to apply this policy in order to enable collecting all the traces between mesh, and we'll just do mesh trace all. So every communication that happens with the service mesh will include tracing headers, so we can start collecting this data inside the Jaeger. So let's see if we save and test. And now a data source is up and running. So the Grafana can connect to Jaeger, and the Jaeger actually have some information about the traces, because we start collecting this data for service mesh. So this works. We're going into Loki. Let's see if the Loki be able to collect the logs for our application. Yes, it does. We also need to enable this policy called a traffic all logs. So all the services will collecting this thing, kind of things. So the last but not least, we just do traces. We did the logs. Let's do traffic log all the traffic. So we will be able to collect all the traffic. Again, insomnia continues to hit my application. My traffic is collected. So now if I go to some of the dashboards, let's take a look. I'm going into my Kuma mesh dashboard, and automatically we've just enabling this, the interception of the traffic, and enable those things. Our control plane will be able to collect enough information in order to automatically visualize what happens with our application. So traffic comes into gateway, goes into work application, and work application will call in meeting application. So immediately, without doing anything in your applications, you will be able to see this visualization of the things. And the last but not least, I want to show you how you can quickly investigate if there you have any problems. You can go and search by the service. So have a mesh gateway, and we can see all the traces that are available for this. From the mesh gateway, we will be able to see that all this traffic that comes, and we can see the logs. Let's see, we have this work application, refresh. all the traces that comes to the work application going from this is our meeting application and the responses that it will send back and forth. So all this information automatically collected by just enabling those policies. Like every time we're calling, we will be able to get all this information because the traffic traces were injected automatically in every request that we have here. Let me before we done, let me actually break something so you would see this thing actually works. So there is a fault injection policy that allows me to inject 50% of problems inside this application. So 50% of requests that comes from one application, meaning that from the responses from the meeting application to work application will have a 500 status. So meaning that I only will be able to attend only few meetings, not the 4 meetings, but 2. So let's see how it goes. Kubernetes control apply, mesh and /fi. And once I did this, immediately I will be able to see where's my dashboards. If I go to mesh, immediately I start seeing these errors start piling up. The requests will be failing, and in my insomnia will be giving me only 2 requests out of 4. Like 50% of requests will fail. Sometimes 3, sometimes 2, but it actually works. We just introduced a problem inside this application, the traffic flow, without changing application code. I think that's very powerful. All right. So that's the last slide or last part of this thing. Again, this thing is available to you. You can play around with this on your own. You can play around with this traffic. You can with this code. You can play around with different policies. For example, like I like to use this fault injection as a kind of like example of how people can model different situations where their applications are failing, and how they would be able to see how their application handles all these type of problems. So again, don't forget to subscribe to our YouTube channel. Subscribe, enable notifications. I'm not getting tired of telling this. We have a ton of cool content around cloud connectivity, microservices, service mesh. Everything is available for you on our YouTube channel. My name is Viktor Gamov, as always, and as always, have a nice day. Don't forget to subscribe to channel and my Twitter.